Alrighty, Ms. Whitaker here, and I wanted to go over the test review. And this particular portion is about squares and square roots. This is 7.1c. That's our expectation from the state. It says to represent squares and square roots using geometric models. So this is mainly about the models. However, we talked about what squares and square roots are. Squares is whenever I square a number, and we got to remember that 3 squared doesn't mean 3 times 2. It means 3, 2 times. 3 times 3 is 9. 4 squared is 4 times 4. That's 16. So don't forget what a number squared means, what an exponent of 2 means. Don't forget that. We also know that models of squares and square roots they're always going to be in the shape of a square. Always in the shape of a square. Never a rectangle, as we're going to see in this first problem right here. So let's just get right into it. Model is always a square. It says the model at the right represents square root of 49 equals 7. The reason why this is the model for the square root of 49 is because there are 49 individual squares, and it's also a 7 by 7. Now we go back to area, because area of a square is side squared. So that's why our model's always going to be in the shape of a square, because in this particular model, 7 squared equals 49. So that goes back to our two-dimensional measurement. All right, so it says this model's square root of 49 equals 7. Which arrangement of small squares can be used to model a large square that represents square root of 196? All right, I'm looking for a square that will be a model for the square root of 196, and I notice that it will be in the shape of a square. A model for square and square roots is always in the shape of a square. Now, when I look at my answer choices, I immediately see that 4 by 49, 4 rows of 49 little squares, if I multiply that out, I think that does give me 196 little squares. However, 4 rows of 49 is going to be a rectangle. It's going to be like a short and long 4 rows of 49 squares. That's not a square. So for that reason alone, that's not going to be my model for the square root of 196. 6 rows of 36, again, is a rectangle. And I think it turns out to be like 216 little squares anyway. All right, a 12 by 12. Now that does make a square. However, it's going to be 144, not 196. So that's not it. A 14 by 14 is in the shape of a square, and it's also going to give me 196 little square units. So that's my model. Now remember, it cannot be these two because those are rectangles. My model is always going to be in the shape of a square. And 12 by 12 gives me 144. Please look at every answer choice. Look at it, draw pictures, do whatever it takes to make sure you have the right answer. And it's really important to look at every answer choice, because you just might overlook the right answer because you prematurely answered when you should have looked at all of them. You should be comfortable with 3 of them disqualified and 1 right answer. All right, let's move on. Let's move on down to the next problem. All right, it says which model represents 8 squared? 8 squared is 64. So I'm looking for a model in the shape of a square. So that's not it. That's a cube. That's not it. And this looks like it's 2 rows of 8. That's not it. This is an 8 by 8, 64 square units. That's my answer. This is 8 squared. That model's 8 squared. 8 on each side. 8 squared equals 64. All right, next page. Which model represents 9 squared? So I'm going to be looking for a square that's 9 by 9. And that's obviously going to be G. This is not 9 by 9. That's 9 by 1. This is 9 by 2. So that's not it. And I'm guessing before I even see J, well, that's just some odd little crossword shape. So nope, that's not it either. It's always going to be in the shape of a square, so keep that in mind. The answer is G. All right, number 2006, number 39. These are all taken from previous tax tests. The model below can be used to represent the area of a square with a side length of square root of 25 units. So that's my side length of square root of 25 units. What's another way to represent the side length of the square? Well, look at it. This is representing square root of 25, which is what? Square root of 25 is 5 because 5 squared equals 25. All right, so if the square root is 5, my side length, obviously, just looking at this square, the side length is 5. So I need another way to represent the side length besides square root of 25, and that's going to be 5. So I look at my answer choices, only look for the one that equals 5. 125 is not 5. 5 is 5, but can it be that easy? Square root of 125. I do not know on C, square root of 125. It's not a perfect square. I know it's between 11 and 12. It's closer to 11, but it's certainly not 5, so that's not it. And square root of 5 is between 2 and 3, because I know the square root of 4 and the square root of 9. Square root of 5 is not 5. Please don't make it so. 5 is 5, and yes, it's that easy. That's the square root of 25. That represents the side length. So read the question carefully and answer it accurately. Do not make up your own answer just because you think 5 is just too easy. All right, let's move to the next one. 2009, number 7. It says the model below is a square with an area. Actually, there's no model, so you can just draw one if you want to. Area of 144 square units. Which of these equations can be used to determine S, the side length of this model? So what is the side length when my area is 144? If the area is side squared and my 144 equals side squared, I can take the square root of both sides. Square root of S squared is going to give me S. Square root of 144 is going to give me 12. I know that my side length has to be 12. So I'm going to look now at all my answer choices to see what's going to be a side length of 12. Well, the square root of 144 is 12. But I'm not going to stop there. I'm going to look at all my answer choices just to be sure. 12 to the 12th power. That's 12 times 12 times 12 times 12. That just keeps going. It's a huge number, so I know that's not it. 144 is 144, not 12. And square root of 24 is almost 5 because it's almost the square root of 25, which is what I know. So that's not it either. The only one that gives me an answer of 12 is letter A. Make sure you look through it, all the answer choices. Make sure you know the question carefully, and you won't go wrong. All right, let's move on. Next problem. It says Jeffrey cut a square piece of graph paper so that each side of the graph paper had 8 small squares along the edge. He wanted to know how many of the small squares were on the piece of paper he cut. So this is an 8 by 8, right? 8 by 8, and you can count it. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We have an 8 on this side, an 8 on this side. So which expression can Jeffrey use to find the number of small squares on this piece of paper? 8 times 2, is this 8 times 2? No, it's not 8 times 2. That's not 16 little squares. 8 to the 4th power is 8 times 8 times 8 times 8. That's a really big number. Too many for this piece of paper. 8 times 4 is 32. There are not 32 little squares on there, and that's not how I do squares and square roots anyway. So my answer is 8 squared, which is 64, and that's going to give Jeffrey the answer that he needs. All right, so that's squares and square roots. Just make sure you always know they're always in the shape of a square, always a square. And this comes from the area formula for a square is side squared. And so if I have the area, I can just take the square root of the area to find out what my side length is. So we also talked about perfect squares. Make sure you know your perfect squares. I'd say up to like 20. But you can do it out on paper if you need to. Know your perfect squares, so if you need to estimate, you can do that. And if you have any questions, just let me know.